Good morning, boys and girls. Are you ready today to learn about atomic structures?
Yay!
Now, who is ready to learn?
Me!
Now, let's get started. Write down on your boards, atomic structures. Atomic structures of an atom consisting of a positively charged nucleus with protons, which are positively charged, and neutrons, which have no charge, which are surrounded by negatively charged electrons.
Wow, that's a mouthful, Dr. Wilkins. Can you give me a better breakdown?
Why, of course, Pat. An atomic structure is broken down into 3 different types of subatomic particles.
What is a subatomic particle, and what are the 3 types?
Well, Joe, I'm glad you asked about subatomic particles, because subatomic particles is any various particles of matter smaller than a hydrogen atom. And do you want to know the 3 types? The 3 types of subatomic particles, write this on your boards, subatomic particles the 3 types. The first one is protons. Can you say protons, Patrick?
Protons.
The second one is electrons. Can you say electrons, Patrick?
Electrons.
And the final subatomic particle is neutrons. Can you say neutrons, Patrick?
Neutrons.
There you go.
What are the roles for these 3?
Well, Patrick, that is an excellent question. I'm so glad you asked. A proton is a positively charged particle within the nucleus, and it has a mass. So proton, positively charged particle within nucleus and has a mass. An electron is a negatively charged particle that revolves around the nucleus and has no mass. Negative. Around nucleus has no mass. And lastly, neutrons have are neutral particles located within the nucleus and do have a mass. So neutrons located within nucleus and they do have a mass. An example of a subatomic particle would be lithium. To show you examples, I'm going to draw the atom of lithium and show its subatomic particles. Lithium, so we have 3 neutrons, 3 protons, and as you can see, they're both within the nucleus, and surrounding the nucleus on the first ring we have 2 electrons, and then on the second ring surrounding the nucleus is the 3rd electron.
Dr. Wilkins, isn't there something called atomic and mass number?
One more peep out of you and you're going to detention, son. Now, like Joe said, atomic number shows the number of protons in within each atom. It is specific for each atom and shown with the letter Z. So atomic number can be categorized with the letter Z. An example of where the atomic number is within an element on the periodic table, let's say oxygen, oxygen's atomic number would be the number 8. Now, moving forward, the mass number is the mass of a neutron is approximately equal to the mass of a proton. The mass of an atom is equal to the sum of the mass of protons and neutrons we show. The mass number can be categorized with the letter N. So mass number can be used with the letter N. Now, within an element on the periodic table, you can use the mass number is located right here, going back to oxygen. This would be considered the mass number. Now, Joe, did that answer your question?
Yes, sir.
The last and final lesson for today with atomic structures, Patrick, is about isotopes.
Oh, that sounds cool.
You know what, Pat? It really is kind of cool. Isotopes have the same atomic numbers, but different mass numbers. Write isotopes down on your board. So they have same atomic numbers, but different mass numbers. Since the number of protons are equal, chemical properties of the atoms are the same. For example, 1, 1H, and then 1, 2H, then 1, 3H. This can be classified as an isotope because when you add the protons and the neutrons together, that protons and the neutrons, it gives you 2. And then when you add the protons and the neutrons again, it gives you 3, and so on and so forth.
I just love chemistry. Thanks for an amazing lesson today, Dr. Wilkins.
Of course, kids. Anytime. Until next time, stay clean. Such a great gift.